Hey everyone, it's Justin again. In the last lesson, you learned how to multiply polynomials together, either by using the FOIL method or a distribution pattern. As you practice, you might notice that sometimes weird things happen. In this video, we're going to talk about one of those weird occurrences, when you multiply binomials and the result is a difference of squares. By the end of this lesson, you will be able to recognize binomials that multiply to make a difference of squares and use a shortcut to find their product. To obtain this skill, first we'll take a look at what a difference of squares is and what causes it to happen. From that knowledge, we'll be able to write a rule for difference of squares, which we'll use as a shortcut and 3 example problems before you try one yourself. What would we get if we multiplied these binomials together? Let's use the FOIL method. First, outer, inner, last. And because we have like terms, we need to combine them. 3x combined with negative 3x is 0x. And 0 times anything is 0. And adding 0 doesn't do anything, so we can get rid of it. So the middle term zeroed out and disappeared? All we're left with is x squared minus 9? Yeah. That's exactly what happened. We call this result a difference of squares because that's exactly what it is. 2 squares, x squared and 3 squared, being subtracted, hence the difference. But what causes us to get this difference of squares with no x term in between? Let's backtrack. The missing term went missing because of these terms zeroing out. And these terms were the result of x times 3 and negative 3 times x. The terms we multiplied to make them were the same thing, just with a different sign, one positive and one negative. So they ended up opposites, which zeroed out. So then we could write a rule for difference of squares. If you multiply 2 binomials that are identical, except one sign is different, the resulting product will be the square of the term with the matching signs minus the term with the different signs. Let's try another example using the difference of squares rule. X plus 5 times x minus 5. As you can see, these are nearly identical, except for one sign. That's all it takes for a difference of squares. Since this meets the criteria, we can skip some steps and assume the product will be the square of the terms with the same sign, x times x, making x squared, minus the square of the term with different signs. 5 times 5 is 25. We could always work this out the long way by using the FOIL method, but it's just more steps to get the same result. I know this looks weird, but look a little closer. These binomials are almost the same, except one sign is different. So yeah, this will make a difference of squares. And the best part, the product is going to look a lot nicer than this current mess of signs. Square the terms with the same sign, x times x, and subtract the square of the terms with different signs, 2 times 2. That looks much better. And just like before, if we FOIL this out, we will get the same result. It's just a lot more work because we have to be extra careful with these signs. Any almost identical binomial pair can create a difference of squares, even ones with higher degrees. X cubed squared is x to the 6th power, and 7.3 squared is 53.29. Would we typically be able to identify this as a difference of squares? Probably not. But by knowing what happens when we multiply nearly identical binomials like these, it keeps us from doing unnecessary work for terms that will just get canceled in the end either way. Why don't you try one? Pause the video and see if you could find this product without using the FOIL method. The method for multiplying these probably isn't a surprise. After all, what's this lesson on? Binomial multiplications that produce a difference of squares. 2 binomials, identical except for one sign, so square the term with identical signs and subtract the square of the term with different signs. Ta-da! This probably wasn't a very difficult lesson for you, but there's a reason we're focusing on it. By knowing where a difference of products comes from, Later on, when we need to reverse this process, we can easily do so by recognizing that a difference of squares comes from multiplying binomials with nothing different except a single sign. So that's one special product down. The next one we'll look at is called a perfect square of binomials. What happens if we multiply two binomials that are exactly the same? Tune in next time and find out. See you then.